Today we're going to be creating a diagram that shows the seasons, the motions of Earth, our rotation and revolution, and kind of some of the effects that we see. We've been talking about a lot of different things this last week, but I wanted to make sure that we put all of those pieces together and really understood how they fit in Earth as it rotates around its axis and as it revolves around the sun. So the first thing that you're going to do is write a title at the top of your paper. I'm doing this online, but I want you to do this on paper, please. So you are going to write down seasons diagram on your piece of paper. Then you need to write your first name and your last name in the top right-hand corner along with the class period. And in the top left, we're going to draw a compass rose. A compass rose is a tool that we use to show the cardinal directions, or which way is north, east, south, and west. So if you look up here, we've got north, east, south, and west. So this is what we're going to put in the top left-hand corner. You do not have to put northeast, southeast, southwest, and northwest. But if you'd like to, you can. So go ahead and at this time on your paper, label the title, write the title, put your first name, last name, class period, and add your compass rose. After you've done that, the center of our solar system is the sun. So you need to draw a sun in the center of your page. Once your sun is finished, we are going to draw the earth. We are going to draw the earth and how it rotates. So you need to draw the earth along with its tilted axis. So this axis is tilted about 23 degrees. And then I've drawn an arrow, a red arrow here to show you which direction the earth rotates. After you've done that, you're also going to draw four Earths total, so 3 other Earths. And we are going to break these down by season here in just a few minutes. But I need you to go ahead and start here. So pause your video and continue drawing. Now, if you remember, the sun looks like it rises or it starts the day in the east, and it sets or goes down in the west, which really means if the sun rises in the east and sets in the west, that the earth moves from the west to the east. So if you notice, if you look at your compass rose up here, the west is on this left side. Our left side then moves to the right side, which is west to east, west to east. And that's why my arrow I tried my best to make it look like it starts on the back side of the earth, moves around the front, and then rotates backwards. So we move from the west to the east. Now, the other really important line we need to make sure that we have is our equator. So our axis moves up and down through the center of the earth. Our axis is that invisible or imaginary line that the earth rotates around. The equator, we use that line to divide the northern and the southern hemispheres. Okay, so we really need to understand both of those lines and where they are because they're both imaginary lines. When we draw these, they're going to intersect or they're going to make a T or maybe an X. So please make sure that you're not drawing your line just all the way through and thinking you have both your equator and your axis, because our equator moves north and south and our the axis moves north and south, and our equator moves east and west. Now, we talked about the equator always getting direct sunlight. So if we think about that, and you don't need to draw this, but if we have a line coming straight from the sun towards the earth, which area of the earth is getting the most sunlight? If I have sun energy leaving the sun and heading towards the earth, it's going to be right here towards the center of the earth. Now, I could also add a little bit more south and a little bit more north here. And then once we start getting to that rounded edge, the rounded edge of Earth, that's when we start to get our indirect sunlight. And that's where it hits. And when we did our flashlight lab, and that when we turn the flashlight at an angle, it's spread out across Earth's surface. So at the North Pole and towards the South Pole, or even down here by just the southern hemisphere, we have a lot less heat and a lot less energy. It's spread out. So that's what's going to be giving our seasons. So now what I want to do is, on your piece of paper, you're going to label the seasons in the northern and southern hemispheres. So our northern hemisphere right here is going to be summer. And I know this is summer because it's getting the most direct sunlight. Just like I drew my arrows there, I'm going to write this a little bit bigger so it stands out. I do want to have rotation just on this Earth. I'm not going to put it on any of the other ones, but I do want to put that there. So then we also have our season in the southern hemisphere. So if we have summer in the north, our southern hemisphere is going to be winter because it's getting much less sunlight down here at the southern hemisphere. Still some. It doesn't mean it's necessarily super cold, but it just does have less energy, less heat compared to other times of the year. So just to kind of keep things organized, I'm going to put these over here on the side, and I'm going to put a line in between them so that I know what I'm looking at is the northern and southern hemisphere. The north will be on top and the south will be on the bottom. My line's going to be tricky, but at this time, go ahead and pause the video and label summer in the northern hemisphere for this globe right here and winter in the southern. So now that we have our first globe, our first model of Earth rotating with summer in the northern hemisphere and winter in the southern hemisphere, we're going to do the same thing for our other globes. Now, before we label our other seasons, it's important for us to make sure we know which way the Earth revolves. And the Earth revolves counterclockwise, the same direction that it's going to rotate. So I'm going to draw arrows here that show the Earth's revolution around the sun. I'm also going to label it. So I'm going to add a text box, but you're just going to write revolution. I'm also going to make my font blue and my lines blue just so that it helps me kind of piece those two things together. I know that random blue word goes with my revolution. So at this time, go ahead and make sure that your page is updated, that you have summer and winter, and you also have your arrows and your label showing which direction the Earth revolves. Now that you've finished that, we're going to go ahead and label the rest of our seasons. And we talked about making sure we understood the revolution because when I move from this globe to this globe, if I think about the order of my seasons, I should be able to pretty well determine which season is next in the northern hemisphere and which season is next in the southern hemisphere. But we also need to be aware of where our axis is pointing. So we need to think through that as well. So I'm going to come over here because we've talked about which models are the easiest to identify. So here I have my axis, which is really tilting towards the sun. It's pointing towards the sun. The pole at the bottom is pointed away. Now here, it's not pointed at the sun or away from the sun. It's pointed towards the side. So this one just sort of depends on its previous season. So I'm going to move over here and see if that's easier for me to identify. And in this picture, I have my pole pointed more towards the sun, and my northern hemisphere is away from the sun. So if my pole in the northern hemisphere is tilted away from the sun, it means it's not getting all of that heat energy and it is much colder. So we are going to go ahead and label that season winter. And our southern hemisphere is going to be the opposite. So that's going to be summer. So at this time, go ahead and update your diagram. Now that we've updated that, we're going to go ahead and label the last two models of our Earth. So if we start here, and we know that our pole is pointing towards the sun, so we have the summer. The next season we have is going to be where things start to cool down before they get to our cold, cold winter. So our season between summer and winter is autumn or fall. If we're experiencing fall in the northern hemisphere, that means our southern hemisphere was cold, 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 and things are starting to warm back up. And as they start to warm back up, our plants start to grow, things turn green, we have more rain, and that is going to be spring in the southern hemisphere. At this time, go ahead and pause the video and update your diagram. Now, if we continue through our revolution around the sun, we have 4 seasons within one revolution or 4 seasons within our 1 year. And remember, a revolution takes 365 and 1/4 days. But as we move by, we have our summer when the northern hemisphere is tilted towards the sun, fall as it starts to cool down, winter as we are pointed away from the sun, and then again things have to cool down and we're going to have spring in the northern hemisphere. So winter starts to warm up, plants start to grow, things turn green, starts to rain, and then we reach the really hot time of our year, summer, where things start to dry out a little bit. But back up to this model, if we have spring in the north, we have fall or autumn in the south. And that is going to be our diagram of the seasons. So at this time, pause your video and make sure that your page is up to date. Now, the next thing that we're going to put into our diagram is something that you're going to read with me about one day this week, if you haven't already done so. But we are going to talk about the summer solstice, winter solstice, autumnal equinox, and spring equinox. Now, what those are, and like I said, we'll talk more about them later too, but when the earth is rotating as it starts to tilt towards the sun, it's almost as if the northern hemisphere here in the summer wants to stay in that sun longer. So the sun, it's bright early and it stays bright for a long time, all day. It's tilted towards the sun, again, almost like it just doesn't want to let go. And if you think about it, in the summer, our days are longer. We have a lot of sunlight. Right now, I don't know if you have noticed, but I feel it. But in the winter, as we continue to move from fall to winter, I can feel the days getting shorter. That darkness comes a lot earlier, where now it's maybe 6 o'clock before the sun goes down and it's dark outside. So the seasons not only change our weather, and the vegetation, the plants and animals that we see, but it also changes the length of our day. So when the earth is tilted towards the sun or facing towards the sun in its rotation, we're experiencing daytime. And as we move behind the earth's shadow, or behind, almost where that, when we move behind the back half of the globe, we are back in Earth's shadow. So if I were to draw something to help you see that, if I drew a line here through our Earth, make this a little bigger. So let me get rid of this line, sorry. All of this area would really be in the sunlight, which means all of this area is in the darkness. It's in the shadow of Earth's globe, that round circle. So if the northern hemisphere is in the summer, all of this is daylight. But only this smaller sliver over here is darkness. Now, if you look at the southern hemisphere where they're experiencing winter, these days are shorter. This is a smaller time when we're facing the sun. So this backside is much darker. That's our nighttime. So if we're in the sun for a longer time, that means our daylight hours are much longer. Now down here, if we're in the sunlight or facing the sunlight for less time, we have more nighttime. So at some point, we experience what we call a solstice, and that is just the most extreme amount of light. So in the northern hemisphere here, this is the most sunlight that we're going to get. Okay, it's a day or two of the year where we really have a lot of sunlight, the most sunlight we're going to have before it starts to move back towards winter in the northern hemisphere. And we just call those our summer and winter solstice. So summer solstice will be in the northern hemisphere in this diagram, and our winter solstice will be in the bottom hemisphere. So at this time, go ahead and label those words. Now in the northern hemisphere, we experience our summer solstice on June 21st. About. Now, sometimes that changes a little bit because as we revolve around the sun, we have that quarter of our day that kind of changes our position just a little bit. But I do want you to add the date for that. So if you think about it, June is a summer month for the northern hemisphere. So it's going to be in the middle of that summertime, when we're experiencing the most direct sunlight. So you're just going to have to remember that all of them are 21st, 22nd, but June is when we have our summer solstice in the northern hemisphere. It's the middle of summer. It's when we have the longest amount of daylight before our days start to get shorter. So if we have our summer solstice in the summer, In the northern hemisphere, it means we are going to have our winter solstice during our winter time. So we're going to label this one as well. And our summer solstice for the southern hemisphere happens on the same day because it's going to be when the northern hemisphere is tilted away from the sun as long as it possibly can, and the southern hemisphere is tilted towards the sun as long as it possibly can. It is the longest and shortest day of the entire year for either of the hemispheres. And that takes place typically on December 22nd. So go ahead and label that as well. So the middle of winter, the shortest day of the year, the least amount of sunlight, our winter solstice. So at this time, go ahead and pause your video and make sure you have these dates written down for our solstice, or when our sun is we have experienced either the most sunlight in a day, the longest daylight hours, or the shortest amount of daylight hours. After you've labeled your summer solstice and your winter solstice, marking the longest and the shortest days of the year, we're going to talk about our autumnal equinox and our spring equinox. Now, if you think about those words, we kind of talk about autumn or fall. We use those words interchangeably in English. Autumnal means it's taking place during our fall time, our fall season. Now, equinox, if you think about the word equal, it means that it's the same on both sides, or the same. So when we think about autumnal equinox, if here we have the longest day of the year, and here we have our shortest day of the year in December, halfway in between the longest and the shortest, we have to have an equal day. So that's where we experience our autumnal equinox in the northern hemisphere. And the same thing for the southern hemisphere. If this is the shortest day of the year and the longest day of the year, there has to be some time in between where we have about 12 hours of sunlight and 12 hours of darkness. And that is most recently going to take place about March 20th. Now, again, these dates kind of change a little bit based on our position in our revolution, but you really need to know that it's June, March, December, and then our next ones are going to be in September when we talk about our. I'm so sorry, I messed up my dates here. This is going to be for our spring equinox, because if you think about it, our spring takes place in March. So that's, just kind of how you can think about which one is where. So our date for our autumnal equinox is going to be September. And this one most recently is going to be September 23rd. But that's going to be our most balanced day of the year in the fall. Our most balanced day of the year. So 12 hours of sunlight, 12 hours of darkness. And again, that you hear the word equal in there, equal. And then in other languages, now I, as nerdy as it might be, like to play Nazi zombies on Call of Duty. And there is the very first level that you play when you're playing World at War is Nocturne Untoten, which means Night of the Undead. So that's actually how I remember equal night. Nacht is night in German. So sort of a roundabout way to explain that, but equal night, because nox means night. So then equally up here, we have a spring equinox and an autumnal equinox. And again, we already have our date up there. That is March 20th. Our spring equinox is going to be when we have half sunlight and half darkness. And the same thing for the southern hemisphere. Theirs is going to just be the opposite. It's still equal sunlight and equal darkness, but it's taking place during fall or during their autumn. So again, if we just kind of think about like these dates and kind of what these words mean, if we're looking at a solstice, we're looking at the sun and how much sun we have within a day. In the summer, we have sunlight, what seems like a lot longer. It seems like a whole day of sunlight almost, with just a little bit of darkness at night. So we're looking at the sol. We are looking at the sun to see how much sun there is. It's either the longest day for summer or the shortest day for winter. But a rotation still takes 24 hours. So we're just looking at how the daylight actually changes. For the equinox, equal night, equinox, equal night. And then again, our solstice, we're looking at how much sun there is. So as we revolve around the sun, we start with the longest day in the northern hemisphere, and then things starts to get shorter, less sunlight, less sunlight, less sunlight, until we have 12 hours of sunlight and 12 hours of darkness. And then we move to the shortest day of the year, December 22nd, 23rd. Things get darker, the darkest day of the year, the least amount of sunlight. And then the day has to get longer. It can't get any shorter because that was our darkest day. So then things start to get brighter, more daylight, more daylight, more daylight, until again they are equal for our spring equinox in the northern hemisphere. And then things continue to get brighter and brighter and brighter until again we have our longest daylight in June 21st, 22nd, and so on. So we just get longer days, equal days, shorter days, longer, longest, equal, short. Okay. So make sure that you have this diagram copied down on a piece of paper, please. If you are a full-time virtual student, I'd like for you to take a picture of this and send it to me. You can use a cell phone and email it to me, or you can use your Chromebook and send it that way. That's fine. If you are going to have problems putting this on a piece of paper, please email me. I would much rather it be on a piece of paper, but if there's an issue, just reach out to me and we'll get that taken care of. Again, we're gonna read and talk about this information as a group, as one of our stations, but this is kind of piecing together our new information and our old information when we started talking about rotation and revolution. So hopefully this helps you to sort of see how they all fit together, and email me if you have any questions. You are going to need to turn in this paper to me whenever you come to class. So they will be due that Friday on the Friday after these stations are all completed. So make sure that this is finished. If you are working on this at home, you're just going to have to turn it in when you come back to school after fall break. But just make sure that you get this finished and turned in to me. If you'd rather take a picture,